Hello? I know. Huh? The bracket down? Brightness down? It is control minus. And brightness up would be control plus. There we go. Alright, isn't that fancy? Alright, so, okay, you guys ready? Does anyone not have these notes? Everyone was here yesterday, right? Okay. Alright, so, okay, good. You got it? Keep going, keep going, keep going to the window. To the window. Not to the wall. You should be, it's like 5.3 there somewhere. There we go. All right, so interpret the integral of a rate of change. Part 2 of the fundamental theory of calculus states that under certain conditions, if f is an antiderivative of f, then, given my bounds from a to b, I would actually have the integration. Remember, when I'm going from lower f to big F, that's going to be the integration or antiderivative, right? So it would be from here to here, right? So the integration of b minus the integration of a, right? Yes? Yes? Okay, good. Okay, since f is an antiderivative of f, then f prime, capital F prime, is equal to f. So taking the derivative of the integration is just going to give you just f, which is going to be the function.
Yeah.
Make sense, or did I just confuse everyone?
Makes sense.
Did I confuse anyone?
Of course.
I'm trying to. Okay, I'm doing my darndest to confuse you on this one, right? So if you take the derivative of the integration, that gives you the function, right? Okay, good. All right. So same thing goes that we have. So from here to here, we get this to this. So taking the derivative, so I have the derivative already. It's going to be the function from a to b. In other words, integral from a to b of the rate of change of f is equal to the change of f from a to b. Okay. Population in the United States is growing at a rate of, p prime of t is equal to that function right there. Millions of people per year, where t is the number of years since 2015. Okay, so since 2015. So that means 2015 represents what? 0, right?
Yeah.
2015 is going to be 0. And what would 5 represent? 2020, right? Okay, good. So what we're going to do is we're going to do the integration of that function, right? So I'm taking the integration. Let me insert page after. Yeah. So it's the integration of from 0 to 5. What was the number on that one?
I think p prime of t is 2.867 times 1.009. Just raised to the t power.
dt, right?
Yeah.
Okay, thank you. Now I have to go and try and figure out some crap here. Remember those cards that I gave you?
You flashcards?
Yeah, the flashcards. Remember the flashcards? Yeah, the flashcard's going to help you out here. So if I'm taking the derivative of something, it's going to give me that. So the derivative of something is going to give me that. So the opposite means the integration of the derivative should give me the function. Okay, so the flashcards, when I have you guys flip them back and forth, right? So if I know, so let's, I'm just talking hypothetically right now, okay? So given those flashcards that I gave you, there's a couple things that you get from this. So if I say, what is the derivative? So I want to know dx of tangent x. What would you tell me? That's going to give you what? right?
Yeah.
So the same thing is if you take the integration of secant squared x, it's going to give you, okay, so this gives you this gives you this. So the integration of secant squared x is going to give you tangent x plus c, right? Okay, but you know the plus c is going to come into it a lot more. But the cards that I gave you guys, the cards that I gave you are going to help you with this because a lot of these things, I don't even remember. There's so many rules, so many things that I'm like, ah, crap. I can't even remember what that one is. So, do you have your cards with you? Okay, so what do you have? Take a look. We got to find, for this right here, what's going to give me that? Because I have to have an integration that's going to give me this.
Is it going to be 2.867 t?
2 point.
Because isn't that the chain rule that they did there then?
Uh-huh.
So then, yeah, so would it be like 1.009 raised to the 2.867 t? Wouldn't that be the antiderivative?
Find it.
What is?
That's a stab.
You're close.
I think there's an
I mean,
in there
I'm
somewhere.
pretty sure there's an ln in there.
Oh, an ln.
The reason why, because I totally forgot. I was looking at my notes this morning and I totally forgot. I was like, oh crap, what is this? Pacho.
Just live stream it for me.
Hey, yo, back. Just like
I'll do it. Cool.
Hope you feel better. Okay. Is that better now? So like I said, there's so many things to remember, it's hard. So if you're going through your flashcards and helping you guys, you're sitting there not doing anything, instead of breaking out your Uno cards and during advisory and just playing Uno, just break out your flashcards, be like, dude, I got this. Okay?
play speed with them.
Yes, play speed with it. Be like, all right. Okay, so that's going to help me out. So the integration of a to t is going to give me a to t over ln a plus c. But I'm going to have bounds on here. So do I use that plus c?
No.
No. Okay, so it's going to be, so this number is a constant, right? That can go in front of it, can it?
Yes.
Okay, so it's going to be 2.867, right?
Yes.
Times a of t, which is going to be all this, over ln of plus c. But do I need the plus c? Say no.
No.
Because I have?
Bounds. Or,
Yep, I have bounds.
yeah, that's what it
Because I'm not going to have a plus c. Because when I'm actually adding and subtracting from my bounds, okay, my definite integral here, so I'm going to have to add a c on my top bound, right? It'd be a plus c on the top bound, but wouldn't it be a minus c on the bottom bound? Yeah. So you're going to have a plus c and a minus c, so those c's are going to cancel out anyway. So it's going to be some constant that you have there that they're going to, they're going to go away. So whatever constant comes up with that, let's say a number 5. I'm going to add 5 to the top, I'm going to add, subtract 5 from the bottom. So that's why with my bounds, they end up going away. All right, so yeah, I'm not mathing this one. Okay, so if you could please calculator this. Point what?
6.
Okay, so 14.661 what? Let's go back to it.
Million.
T represents the what?
Number of years.
Number of years. And the function right here is representing
Millions.
millions of what?
People.
Okay? United States growing at that rate. Okay, from there to there. Okay, so in the context of the problem. In the context of the problem, what does that mean?
It's the rate.
Projected change in the population in millions.
So that's the rate of change over 5 years. So that would be.
I don't like that. So it's projected to change 14.661 million people, right? Okay. All right, so what was the next part? What's the next part say? It says if the population of the United States was 320 million in 2015, what is projected population in 2020? So,
So would be.
do we know what P of 0 is?
Well,
Right?
We can find it.
Yeah, we can, right? We got P of 0, right?
Yeah.
Okay, so we know what P of 0 is.
Okay. Yeah.
So P of 0 is going to give me 320, right?
Yeah, 320 million.
So we know that P of 0 is, okay. And what else do we know?
The change. Yeah. And we also know the P of T.
The rate at which is going to change, right?
Yeah.
So what am I going to do with that information? Do we,
Just add it.
yeah, we basically,
Just add it, right?
yeah, so we know what it's starting off with and we know what it's increasing by, right?
Yeah.
And so projected, we're going to take my initial, which is my P of 0, and add that to my,
Project.
Yeah.
Change.
Yeah, my projected change. So it's going to be about 3.
334.66 million people.
In 2020. That's what that means. Make sense or no? Okay, so take a look at the next one. Marginal profit in dollars, a unit producing and selling X units of a product given by that. Okay. Suppose 100 units have been produced and sold. Find the additional profit P from producing and selling 21 more units. Okay. So what do we know? So 100 units have been produced and sold. Find the additional profit. Ooh, additional profit. Additional profit. So what is going to be my lower bound? What do you think my lower bound should be? If I'm talking about additional profit, is he really trying to sleep right now? Is my voice just that calming and soothing? Should I actually like narrate children's books?
One fish, two fish.
I know, right? Anyway, think about it. Additional profit. Additional profit.
Your lower bound's gonna be your start.
Nope. It's additional profit, right? Okay. So my lower bound has to be? Nope. 100. Because I have initial, suppose 100 units have been produced and sold. Okay. Marginal profit P in dollars per unit for producing and selling X units of a product is given by that. Okay. I want to know what the additional is going to be. So by additional, that word is telling me that it's going to be added on top of, right? So added on top of means that my lower bound is the 100, and the additional would be,
121.
and that's going to be from x to the 1/2 dx, right? Take my integration. It's going to be what? Okay, what do? I add the exponent, right?
Yeah, 2/3 x divided by 3.
What? What?
3 halves.
And what goes in front of it?
That's what I said, like 2/3 x.
Yeah, okay, very good.
Yeah.
From, there we go. Okay, so let me see. That's going to be upper bound. So that's going to be square root of 121 is going to be 11. 11 to the third power times 2 is, I don't know. All right, what do we get on the top? Or are you guys just calculating the whole thing? Okay. Remember, it's always 3 decimals. So 220 point, like that? Is that what you got? Okay, good. All right, so that's the additional, right? Okay. That's how much more I'm making additional profit from the 121 more, right? Yeah, that's what I'm looking for, the additional profit. Already we have profit, but this is the additional profit on top of my first 100. Is that it? Oh, okay, good. Okay. All right, like, subscribe.